Good morning. In the previous class, we have discussed examples on arbitrary period. In today's class also, examples on arbitrary Fourier series. So first example, today's class, first example, obtain the Fourier series of the sawtooth function f of t is equal to e t divided by capital T for small t is lies between 0 to t. So here function, it is not given in terms of x. So here variable is t. In this example, variable is t. Small t is a variable. So first find here period t of this function. So starting point is 0, ending point is capital T. So this is a and this is b. T minus 0, b minus a, capital T minus 0, so that is capital T. So this is a arbitrary period. So equate this with 2L. So L is equal to T by 2 and 1 by L is 2 by T. Now Fourier series of f of t is given by f of t is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos 2n pi t divided by capital T plus summation n is equal to 1 to infinity bn sin 2n pi t divided by capital T. So we need to find here a naught, an, bn. So obviously, so by seeing this function, so obviously this is a neither even nor odd function, means we need to calculate a naught, an, bn. So a naught is 2 by capital T integration from 0 to capital T f of t dt, and an is 2 divided by capital T integration from 0 to capital T f of t cos 2n pi t divided by capital T dt, and bn is 2 by capital T integration from 0 to capital T f of t sin 2n pi t divided by capital T dt. Now we need to find a naught, an, bn. So first a naught. So a naught is equal to 2 by capital T integration from 0 to t. Write f of t. So f of t is capital E t divided by capital T. Integrate this with respect to t. So small t is variable. E divided by capital T is like a constant. Take it outside. So we'll get here as 2e divided by t square integration from 0 to t dt. So integration of t is t square by 2 and limits varies from 0 to capital T, and 2e divided by t square is as it is 2e divided by t square. Take this 1 by 2 also outside. So t square limits varies from 0 to capital T. So in place of small t, substitute capital T. So e divided by t square, capital T square minus 0. In place of t, small t, substitute upper and lower limit. Upper limit is capital T and lower limit is 0. E by t square minus 0. So this is equal to e divided by t by 2 is e by 2. Now calculate an. So an is equal to 2 by capital T integration from 0 to capital T e by t small t cos 2n pi t divided by capital T dt. So e by t, it is like constant, take it outside. So 2e divided by t square integration from 0 to capital T cos 2n pi t divided by capital T dt. So this is a product of two functions. So one is polynomial and other is trigonometric. So apply Bernoulli's rule, integration by parts. So always first function is u. So polynomial is u. Take this as a u, and next is v. Second function as v. So 2e divided by t square t. Integration of this cos is sin 2n pi t divided by capital T 2n pi divided by t minus derivative of this t is 1 and the integration of this is minus cos 2n pi t divided by capital T divided by 2n pi divided by t raised to 2, and derivative of constant is 0. 0 into something is 0. So next terms you will get this as a 0. Limits varies from 0 to t. Now I will take advantage of this sine function and limits as capital T and 0. So substitute upper limit capital T. So capital T get cancels. Sin 2n pi is 0. Upper limit is 0. In place of small t, substitute 0. Sin 0 is 0. Now both upper and lower limit, this sine function is 0. Only you substitute limits for this. This minus and this minus is plus 2e divided by t square 4n square pi square. So reciprocal of this 2n pi divided by t raised to 2 is t square divided by 4n square pi square cos 2n pi t divided by capital T, limits 0 to t. So substitute upper limit as t get cancels, cos 2n pi, and substitute 0 cos 0. So next step is 2e divided by t square 4n square pi square. Now substitute upper and lower limit, 2 1s are 2 2s are, t square also get cancels. Next step is an is equal to e divided by 2n square pi square cos 2n pi minus cos 0. Cos 2n pi is 1, cos 0 is also 1, minus 1 plus 1 get cancelled. So this is 0, 0 into something is 0. So an is 0. Now find bn. So bn is equal to 2 by t integration from 0 to t e divided by t small t sine 2n pi t divided by t dt. So integrate this with respect to t. Again this is a product of two functions and capital E by t take it outside. So 2e divided by t square integration from 0 to capital T sine 2n pi t divided by t dt. So apply Bernoulli's rule, integration by parts. So 2e divided by t square t and integration of this sine 2n pi t divided by t is minus cos 2n pi t divided by t divided by 2n pi by t minus derivative of this t is 1. Again integration of this is minus sine 2n pi t divided by t divided by 2n pi divided by t raised to 2. Again derivative of this constant is 0, 0 into something is 0. So next terms you will get this as a 0. Now limits varies from 0 to t. Now I will take advantage of this sine function and limits also. Substitute in place of small t as a capital T. So both get cancels. Now sine 2n pi is 0 and substitute 0. So sine 0 is 0. So this term is 0. So apply limit for only this term. Take this minus and 2n pi divided by t outside. So next step is minus 2e divided by t square into t divided by 2n pi t cos 2n pi t divided by t. Limits varies from 0 to t. So 2 get cancels, minus e divided by capital T n pi t cos t n pi minus 0. Now here minus e t n pi cos 2n pi is 1. So 1 into capital T is capital T. So these two get cancels, tt get cancels. So we'll get here as minus e divided by n pi. Thus required Fourier series is f of t is equal to a by 2, a naught by 2. A naught by 2 is e by 2 minus e divided by pi summation of n is equal to 1 to infinity 1 by n sine 2n pi t divided by capital T, because an is 0. So this will be the required series. Now move on to second example. If f of x is equal to 2 minus x, x lies between 0 to 4, and f of x is equal to x minus 6 and x lies between 4 to 8. Now express f of x as a Fourier series and hence deduce that pi square by 8 is equal to summation of n is equal to 1 to infinity 1 divided by 2n minus 1 raised to 2. Now first find the period of this function. So it is a function is divided into two sub-functions. So 0 to 4 in this interval 2 minus x and 4 to 8 in this interval x minus 6. Now starting point is 0, ending point is 8. So period period t is b minus a is 0 and b is 8. 8 minus 0 means we'll get period as a 8. Now this is an arbitrary period. So compare this with 2L. So you will get L as a 4 and 1 by L as 1 by 4. Now substitute L as L as 4 or 1 by L as 1 by 4 in arbitrary Fourier series. So we'll get here as f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x divided by 4 plus summation n is equal to 1 to infinity bn sin n pi x divided by 4. Now we shall check for even and odd nature. So we may get even function or odd function or neither even nor odd function. So here discontinuous function. So first identify phi of x. So phi of x is 2 minus x and psi of x is x minus 6. Now this interval is of the form 0 to 2l, is of the form 0 to 2l. If suppose interval is 0 to 2l, to check whether the given function is even or odd, so we substitute x as a 2l minus x. So in place of 2l in this example we have 8. So substitute x is equal to 8 minus x where in phi of x. So phi of 8 minus x is equal to 2 phi of 8 minus x is equal to 2 minus in place of x 8 minus x is equal to 2 minus 8 plus x. So we'll get here as x minus 2 minus 8 is minus 6. So this is nothing but psi of x. So you observe here phi of 8 minus x. So this is nothing but what? X minus 6. X minus 6 is nothing but phi of x, means the given function is even function. So consequently bn equal to 0. We need to find here a naught and an. So a naught is equal to 2 by l integration from 0 to l f of x dx. In a naught is equal to, in place of l substitute 4, 2 by 4, 2 ones are 2 twos are. So 1 by 2 integration from 0 to 4 because 4 l is 4 f of x dx. So a naught is equal to 1 by 2 integration from 0 to 4 2 minus x dx. 1 by 2 integration of this constant is constant into x minus integration of this x is x square by 2. Limits varies from 0 to 4. Now a naught is equal to 1 by 2 2 1 by 2, right, 2 into x limits varies from 0 to 4 minus 1 by 2 x square varies from 0 to 4. Substitute upper and lower limit 1 by 2 and this 2 is as it is. In place of x 4 minus in place of x 0, upper minus lower minus 1 by 2 in place of x 4, 4 square is 16 and in place of x 0, 0 square is 0 only, and 16 minus 0 is 16, 16 divided by 2 is 8 and 2 into 4 is 8. So 8 minus 8 plus minus 8 both get cancels. 1 by 2 into 0 is 0. So a naught is 0, a naught by 2 is 0 only. Now find an. an is equal to 2 by l integration from 0 to l f of x cos n pi x by l dx. So l is 4, substitute 2 by 4, so that is 1 by 2, 2 ones are 2 twos are, integration from 0 to 4 f of x cos n pi x divided by 4 dx. Now in this interval 0 to 4 f of x is 2 minus x. So substitute function is 2 minus x. So next step an is equal to 1 by 2 integration from 0 to 4 2 minus x cos n pi x divided by 4 dx. Now it is a product of two functions. Apply Bernoulli's rule, integration by parts. So an is equal to 1 by 2. U is always first function, or it is a polynomial we take as a u. So 2 minus x integration of this cos n pi x divided by 4 is sin n pi by x divided by 4 divided by n pi by 4 minus derivative of this 2 minus x is minus 1 and integration of this sin n pi by 4 x divided by n pi by 4 is minus cos n pi by 4 x divided by n pi by 4 raised to 2, and derivative of this minus 1 will be 0. 0 into something is 0. So next terms you will get this as 0. Limits varies from 0 to 4. So substitute. I'll take advantage of this sine function and substitute in place of x as a upper limit, that is 4. 4 get cancelled. Sin n pi is 0. Lower limit is 0. Sin 0 is 0. So for both upper and lower limit this sine function is 0. now left with this. So this minus is plus, and again minus, and 1 divided by n pi divided by 4 raised to 2. So taking reciprocal, so we'll get an as 1 by 2 minus 16 divided by n square pi square cos n pi x divided by 4, limits 0 to 4, because sine n pi and sine 0 both equal to 0. So minus 1 by 2 into 16 divided by n square pi square cos n pi by 4 x, limits varies from 0 to 4. So 2 ones are 2 8s are minus 8 divided by n square pi square cos n pi minus cos 0. Substitute upper and lower limit. Upper limit 4, you substitute 4 get cancels, cos n pi. So in place of x, lower limit 0, cos 0 is 1. 8 divided by n square pi square is 1 minus 1 raised to n. Now this but 1 minus 1 raised to n is 2 when n is odd, and this equal to 0 when n is even. So we may write this as 8 divided by n square pi square into 2, or 16 divided by n square pi square. But one restriction is there. We have to take n as a odd numbers, n as 1, 3, 5, 7, so on. Thus the required Fourier series is given by f of x is equal to a naught by 2, 0 plus summation n is equal to odd. We are taking odd numbers 1, 3, 5, so on up to infinity. 16 divided by n square pi square cos n pi by 4 x plus bn is 0. And f of x is equal to take 16 by n square outside, summation of n is equal to 1, 3, 5, so on up to infinity, 1 upon n square cos n pi by 4 x. So this is a Fourier series, but we want that result. So for that, substitute this x equal to 0 by taking x as a 0. So you will get this as a 1. So substitute here x as 0 in this series. So put 0. So first find f of 0. So this is 2 minus 0. So this is 2, because f of x is 2 minus x, because we have taken interval as 0 to 4. In that interval, we have f of x as a 2 minus x. So in place of x, substitute 0. 2 minus 0 is 2. Now f of 0 is equal to 16 divided by pi square, summation odd values of n. N is equal to 1, 3, 5 up to infinity, 1 by n square cos 0. So 2 is equal to, because f of 0 is 2, so this is equal to 16 divided by pi square, summation of n is equal to 1, 3, 5, so on up to infinity, 1 by n square, and 2 ones are 2 8s are. So this gives pi square by 8 is equal to summation of n is equal to 1, 3, 5, so on up to infinity, 1 divided by n square, right? So here 1, 3, 5. So these are odd numbers. So we can replace this n as a 2n minus 1, because n is equal to 0, n is equal to 1, 2, 3, so on. Because 2n is even, 2n minus 1 is odd. So we'll get as this as pi square by 8 by taking n n is equal to 1, 3, 5, so on. 1 square, 1 divided by 1 square plus 1 divided by 3 square plus 1 divided by 5 square plus so on. So we may write this as pi square by 8 is equal to 1 divided by 2n minus 1 raised to 2. So this will be the required answer. Now move on to this last example. Obtain the Fourier series to represent f of x is equal to x minus x square, and x lies between minus 1 to plus 1. So period of fx is 1 minus 1, that is 2, because a is minus 1, b is 1. So b minus a, 1 minus of minus 1 is 2. Now this is a arbitrary period. So equate this with 2l. So l is 1. The Fourier series of fx having period 2 is given by f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x plus summation n is equal to 1 to infinity bn sin n pi x, because l is 1. So we will get this. Now let us check for even or odd nature. So put x is equal to minus x. Why we are substituting this as a minus x? Because interval is minus 1 to 1. So how it is like? It is like minus L to L. If suppose interval is minus L to L, to check even or odd function, we are substituting x as minus x in fx. So f of minus x is minus x minus x raised to 2. Minus x raised to 2 is x square. So minus x square, take minus common, x plus x square. So which is neither equal to f of x nor equal to minus f of x, means the given function is neither even nor odd. So we shall find the coefficients by using Euler formulae. So a naught is equal to 1 by L. L is 1 by 1, integration from minus L to L, minus 1 to plus 1, f of x dx. So in this interval, function is x minus x square. Now integrate this with respect to x. Integration of x is x square by 2 minus integration of x square is x cube by 3. Limits minus 1 to plus 1, 1 by 2 x square minus 1 to plus 1 minus 1 by 3 x cube minus 1 to plus 1. Substitute upper and lower limit. So a naught is equal to 1 by 2, 1 square minus minus 1 raised to 2, minus 1 raised to 2 is again 1, 1 square is 1, 1 minus 1, so you'll get this as a 0. Minus 1 by 3, 1 cube minus minus 1 raised to 3. So 1 cube is 1, minus 1 raised to 3 is minus 1. So minus into minus is plus. So 1 plus 1 is 2. Multiply this with minus 1 by 3. So you'll get a naught is equal to minus 2 by 3. We want a naught by 2. So a naught by 2 is minus 1 by 3. Now calculate an. So an is equal to 1 by 1 because L is equal to 1. Integration from minus 1 to plus 1 f of x cos n pi x dx. So an is equal to integration from minus 1 to plus 1 f of x is x minus x square cos n pi x dx. Apply Bernoulli's rule, integration by parts. X minus x square is u and cos n pi x is v. X minus x square, integration of cos is sin n pi x divided by n pi minus derivative of x minus x square is 1 minus 2x, and integration of sin n pi x divided by n pi is minus cos n pi x divided by n pi raised to 2. Next, derivative of 1 minus 2x is minus 2. Integration of minus cos n pi x divided by n pi raised to 2 is minus sin n pi x divided by n pi raised to 3. Now substitute. I'll take advantage of this sine function and substitute in place of x as 1 and minus 1. So sin n pi and sin minus sin n pi, so both equal to 0. So these two terms are 0. So this minus into minus is plus. So 1 minus 2x cos n pi x divided by n square pi square. Limits varies from minus 1 to plus 1. 1 upon n square pi square outside. In place of x, 1 and minus 1, upper and lower limit. So substituting 1, 2 into 1 is 2. 1 minus 2 is minus 1 cos n pi minus, substitute minus 1, minus 2 into minus 1 is plus 2, and this plus 1, so this is 3. So 3 cos n minus pi. So cos of minus theta is minus cos theta. So we'll get here as 1 upon n square pi square minus cos n pi minus 3 cos n pi minus 1 minus 3 is minus 4 cos n pi divided by n square pi square. So minus 4 cos n pi is minus 1 raised to n divided by n square pi square. So this is equal to 4 minus 1 raised to n plus 1 divided by n square pi square. Now calculate Bn. So Bn is equal to 1 upon 1 because L is 1. Integration from minus 1 to plus 1. F of x is x minus x square sin n pi x. So integrate this with respect to x. Again use Bernoulli's rule, integration by parts. Now x minus x square, and integration of this sign is minus cos n pi x divided by n pi minus derivative of this x minus x square is 1 minus 2x. Integration of this is minus sine n pi x divided by n square pi square, and derivative of 1 minus 2x is minus 2, and integration of minus sine n pi x divided by n square pi square is cos n pi x divided by n cube pi cube, and derivative of this constant is 0. 0 into something is 0. So b, now here also I'll take advantage of this sine function. So in place of x, substitute 1 sine n pi 0, and substitute minus 1 sine minus sine n pi. So that is also 0. Both are 0. Now this, for this function, upper and lower limit both are 0. So for these two you need to substitute limits. Minus 1 upon n pi x minus x square cos n pi x minus 1 to plus 1, minus 2 divided by n cube pi cube cos n pi x minus 1 to plus 1. So minus 1 upon n pi, in place of x substitute 1. 1 minus 1 square, 1 square is 1. 1 minus 1 is 0. 0 into something is 0. Minus, in place of x substitute minus 1. Minus 1 minus minus 1 raised to 2. Minus 1 raised to 2 is minus 1. Minus 1 minus 1 is minus 2 cos n pi. Right? So because cos of minus theta is minus cos theta. So minus 2 divided by n cube pi cube, in place of x 1. So cos n pi, in place of x minus 1 minus cos n pi. So minus cos n pi. So cos of minus theta is cos theta. So cos n pi plus minus get cancels. So 0 into something is 0. So Bn is equal to minus 2 divided by n pi cos n pi, minus 2 divided by n pi minus 1 raised to n is equal to 2 divided by n pi. So multiply this minus 2, this minus 1 raised to n. So you'll get this as minus 1 raised to n plus 1 divided by n pi. Substitute this in Fourier series. F of x is equal to a naught by 2 minus 1 by 3 plus 4 by pi square, summation of n is equal to 1 to infinity minus 1 raised to n plus 1 divided by n square cos n pi x plus 2 by pi, summation of n is equal to 1 to infinity minus 1 raised to n plus 1 divided by n sin n pi x. So this completes your arbitrary Fourier series. So in the next class, so we start half-range Fourier series. So before that, so I have given some important points. So Fourier series defined in terms of 2 pi and a general interval. So C pi, so interval will be, possibilities are minus pi to pi and 0 to 2 pi. Here same thing, C to C plus 2L, possibility intervals here minus L to L, 0 to 2L. So if suppose function Fourier series is a function is defined in C to C plus 2L, f of x, Fourier expansion of this Fourier series expansion of function is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi by lx plus summation n is equal to 1 to infinity bn sin n pi by lx. So substitute L is equal to pi, you will get a series, a Fourier series having period as a 2 pi. So f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. So if interval is 0 to 2l or minus l to l, so a naught by 2 is 1 by l integration of f of x dx. I have not taken here any limits, because if it is interval is minus L to L, take limit as minus L to L. If interval is 0 to 2 pi, take limit as 0 to 2 pi. So an is equal to 1 by L integration f of x cos n pi x divided by L dx, and bn is 1 by L integration f of x sin pi x bn a naught is equal to 1 by pi integration of f of x dx, an is equal to 1 by pi integration of f of x cos nx dx, and bn is equal to 1 by pi integration of f of x sin nx dx. Because I have not taken any limit, because a function may be defined in the interval minus pi to pi or 0 to 2 pi. If it is minus pi to pi, take limit as minus pi to pi. If it is pi, take limit as 0 to 2 pi. Now even we'll discuss even and odd function. Again, in terms of pi and Fourier series in terms of pi, and in terms of what? Arbitrary, right? Arbitrary means L, and this in terms of period 2 pi means here pi, right? Again, this is divided into minus pi to pi, 0 to 2 pi, and this arbitrary period minus L to L, 0 to 2L. If minus pi to pi or minus L to L, to check the given function is even or odd, so substitute x is equal to minus x. So if you get plus f of x, bn is 0, even function, and minus f of x, odd function, a0 and an both equal to 0. If suppose if it is 0 to 2l, so to check the given function is even or odd, substitute x as a 2l minus x. If it is 0 to 2 pi, substitute x as a 2 pi minus x. If you get plus f of x, even function, minus f of x, odd function, even function, bn 0, odd function, a0 an, both equal to 0. And this is for continuous function. If suppose a function is a discontinuous function and a function is divided into two subfunction, like phi of x interval is 0 to L and psi of x interval is L to 2L. To check the given function is even or odd, if interval is minus pi to plus pi or minus L to plus L, so substitute x as a minus x. If you get plus f of x, even function, bn is 0. If you get minus f of x, odd function, a0 an, both equal to 0. If suppose interval is 0 to 2l, so substitute x as a 2l minus x, or 0 to 2 pi, if it is, substitute x as a 2 pi minus x. If you get by substituting this by substituting 2l minus x or 2 pi minus x in phi of x, if you get psi of x, even function. If you get minus psi of x, odd function, right? So this will be the concept. And similarly for this 0 to 2 pi, so if it is similarly for 0 to 2 pi, right? So if it is 0 to 2 pi, so substitute to check even or odd function, so substitute x as a 2 pi minus x. If you get psi of x, even function, bn 0. If you get minus psi of x, odd function, so a0 and an both equal to 0, right? And here a0 an bn will be like this for odd and even nature. So a0 is, if interval is 0 to 2l or minus l to l, so a0 will be 2 by l integration from 0 to l f of x dx. En is 2 by l integration from 0 to l f of x cos n pi x divided by l dx. And bn is 2 by l integration from 0 to l f of x sine n pi x divided by l dx. If suppose if it is if a function is in terms of pi, so a0 is 2 by pi integration from 0 to pi fx dx. An is 2 by pi integration from 0 to pi f of x cos nx dx. And bn is 2 by pi integration from 0 to pi f of x sine nx dx. So today I'll stop here only. Tomorrow I will start half range Fourier series. Thank you.